A new era of AI has arrived, the age of the fully autonomous AI agent. And the name of the game is Devin. Scott Wu's latest creation is more than just a reliable teammate, it's a highly efficient and independent worker too. With an intuitive interface and a diverse range of capabilities, Devin is truly a groundbreaking breakthrough in AI technology. Will Devin change the way we think about AI forever? Maybe. But first of all, let's unpack what it has for us. Introduction to Devin and its capabilities. Devin is not only a proficient collaborator, but also excels in independent task completion, offering a seamless blend of teamwork and solo productivity. With Devin on board, engineers can focus more on other challenges while engineering teams set their sights on heavier objectives. Leveraging advanced capabilities in long-term planning and decision-making, Devin perfectly navigates through complex engineering endeavors, drawing upon vast contextual knowledge, continuous learning, and error rectification. Equipped with essential developer tools like the shell, code editor, and browser within a secure computing environment, Devin provides all the necessary resources for seamless workflow execution. Moreover, Devin is designed to actively engage with users, offering real-time progress updates, soliciting feedback, and collaboratively addressing design considerations when necessary. Devin can seamlessly navigate through tasks, from browsing the web for API documentation to debugging code and fixing issues entirely on its own. With state-of-the-art benchmarks, Devin sets a new standard for AI capabilities in software engineering. In a recent demo, Devin showcased its ability to start a side hustle on Upwork by taking on a challenging job involving setting up a computer vision model. Despite encountering hurdles like versioning issues, Devin carefully updated code, imported packages, and debugged with precision using print line statements. Continuously improving, Devin refined the code until successfully running the model on images sourced from the internet. Impressively, Devin not only completes tasks but also provides detailed reports, marking damaged roads in sample images and explaining its process. This demonstration highlights Devin's potential to revolutionize the gig economy by automating tasks traditionally done by humans. What sets Devin apart is its capacity for long-term planning, contrary to initial skepticism. As demonstrated, Devin skillfully plans each step, from cloning repositories to reviewing outputs, ensuring the achievement of complex goals. This capability not only enhances efficiency, but also addresses concerns about AI autonomy and safety. Perhaps another impressive feature that differentiates Devin is its ability to reason and plan strategically. Unlike reactive AI tools, Devin can anticipate challenges and devise solutions, just like a seasoned human developer. This capability extends beyond software engineering, offering potential applications in fields like scientific research, where meticulous planning and long-term vision are crucial. Learning from unfamiliar tasks. In one of the demonstrations out there, Sarah introduces Devin's ability to autonomously learn from various tasks. Devin's ability is showcased through a scenario where it generates a customized desktop background image based on a blog post. Sarah explains that Devin does all the work while she sends the blog post, reading it to understand the content and then executing the necessary steps to create the image. Notably, Devin identifies and addresses issues not covered in the blog post, demonstrating its problem-solving skills and adaptability. Similarly, in the second demonstration led by Tony, Devin is tasked with enhancing the user experience of an open-source tool by fixing an issue in its code. Tony, unfamiliar with the codebase, relies on Devin's expertise. Devin navigates through different tools and resources, such as cloning the repository, reading documentation, and debugging compiler errors to successfully implement the requested improvement. Tony confirms the effectiveness of Devin's changes, highlighting Devin's ability to learn and apply new knowledge to unfamiliar tasks. In another scenario, Devin is asked to implement the game of life using React. It starts by creating a new application and writing code, deploying it for the tester to review. It also requests additional features and bug fixes, which Devin addresses one by one. The tester can track Devin's progress through code differentials, verifying each change before moving on to the next request. Devin's iterative approach and responsiveness to the tester's requirements showcase its ability to learn and adapt in real time. Fine-tuning models and test case generation. Moving forward, in another demonstration, Devin showcased its remarkable ability to fine-tune models, which left many impressed. This feature is particularly fascinating because it goes against previous beliefs in the field. Despite initial skepticism from recent research papers claiming that such fine-tuning wasn't possible, Devin proves otherwise, showing how advancements can swiftly debunk established notions. In that demonstration, Devin was tasked with fine-tuning a 7B LLM model using the Cora repository, a method designed for quantizing large language models. Now, it's not all smooth sailing. Devin encounters a few bumps along the way, like some technical issues related to the computer's graphics system. But Devin does not give up easily. Devin looks up how to fix these problems and gets everything back on track. As Devin continues the training process, things start to look really promising. The model's performance improves, and the loss, which is basically how far off the predictions are from the actual outcomes, decreases over time. You can think of it like Devin mastering a new skill with each training session. After a while, Devin informs you that everything is going well, and you can leave the training job running while you go about your day. This ability of Devin to manage tasks autonomously is pretty mind-blowing, right? But Devin's talents don't stop there. Let's say you're a programmer who has created a bunch of code for others to use. One day your friend points out a bug in your code that you had not noticed before. You quickly fix the bug, but then you realize you should probably test the code to make sure it works properly in all situations. Instead of spending hours writing test cases yourself, you decide to enlist Devin's help. You give Devin access to your code repository and explain what kind of test you need. Devin quickly gets to work, writing test cases to check different scenarios and making sure your code behaves correctly in each situation. Devin even comes up with a clever testing strategy to cover all possible inputs, which saves you a ton of time and effort. But here's where things get really cool. Devin doesn't just stop at writing tests. When Devin runs the test, Devin notices something strange. A test fails unexpectedly. Instead of panicking, Devin calmly investigates the issue, identifies the problem, and even suggests a solution to fix it. Devin's ability to debug code and suggest improvements is like having a supercharged pair of programming eyes and brains at your disposal. Furthermore, Devin's performance on benchmarks, such as the SWE benchmark, underscores its effectiveness in real-world applications. Achieving impressive resolution rates for GitHub issues in open-source projects, Devin outperforms previous models, showcasing its robust understanding of code and context. This superior performance, coupled with Devin's autonomy and general applicability, positions it as a leading contender in the field of autonomous AI systems. While the specifics of the technology adopted remain somewhat secret to outsiders, Wu sheds light on the innovative approach his team employed. By ingeniously blending vast language models like OpenAI's GPT-4 with reinforcement learning techniques, they achieved remarkable progress in a relatively brief period. Wu hints at the intricate interplay between models and methodology, emphasizing the crucial alignment required for success. Their success stems from integrating the finest AI techniques available, marking a significant advancement in the field. The future of software development with Devin. No doubt, the coming of Devin brings in a new era in software engineering. We're talking about an autonomous AI agent capable of performing a wide array of software tasks with remarkable proficiency, from debugging code to learning unfamiliar tasks from blog posts. Devin's abilities are not to be underestimated. It can browse the web for API documentation, fix bugs, and even fine-tune its models. What does this mean for the future of software engineering? Well, it's nothing short of revolutionary. Devin's demonstrations showcase its capacity to tackle diverse challenges, from setting up computer vision models on Upwork to adding features to open-source repositories. Its long-term planning and reasoning abilities set it apart, enabling it to autonomously navigate complex tasks without human intervention. The implications of Devin's emergence are profound. It could revolutionize the gig economy by automating tasks traditionally performed by humans on platforms like Upwork. Furthermore, its ability to learn from blog posts and fine-tune its models opens up new possibilities across various disciplines beyond just coding. Most importantly, the competition in the AI space is about to get fierce. With a fully autonomous AI agent that can think, learn, and act on its own, every company will be racing to develop the next best AI solution. Devin could drive innovation in AI research, pushing the boundaries of what's possible with AI technology. And that's just the tip of the iceberg. Devin's potential applications are endless. Are you going to try it out? Let us know what you think in the comment section. There are more groundbreaking technologies on the way, and you can stay ahead by subscribing to this channel. Thanks for watching and see you in the next one.